So this is question 5. We start, discussing sequential circuits now. Okay, this is an analysis question. So um, again, it's part of the final exam of term 2 and 1, and this is question 5. So consider this circuit shown here. Okay, we would like, with output, of course, being Z. Okay, we would like to provide expressions for dA and dB. So this flip-flop is denoted by A, and this flip-flop is denoted by B. And we would like to get the dA, which is this one, and dB, which is this one, right? And Z as well, okay? So just by tracing, okay, the circuit, okay, I can easily say, well, this is X complement, and this is A, and this is coming from, so this other input of the XOR gate is coming from this input here, okay, which is B, okay, A XOR B, right? So this is X complement ORed with A, XOR with B, all right? This is the expression for DA. This is one answer, one of the, or part of the answer. All right, and let us find Z, okay, because it's part of dB, okay. So Z is going to be a complement. This is a complement here, a complement, and did with B. This is B, okay. Same line coming from here, okay. So this is simply Z, which is a complement B. You just need to copy that here in the space. All right. And so we have Z here, okay. And this is going to be X, and this is going to be B complement. So X B complement or the Z. Okay. So my B is going to be a complement B ORed with X B complement. Yeah? X B complement. This is dB. All right. Yeah, let me just copy this over, drag it here because I'm going to need it as well as this one here. Okay. This is going to be Z, and this is dB. So this is dB. I need it to be a little bit here. Okay. And this is dA. This is dA. And this is Z. All right. So is this circuit a Moore or a Mealy circuit? Okay, this is an important question. Okay, in order to answer that, you look at the output. Is the output a function of the present state alone? Then it is Moore. If it is a function of the present state and the input, then it is a Mealy machine. Here, clearly, it is a function of the present state. Okay, so this is a Moore circuit because you can say, I'm not going to write that, but because the output is a function of the present state only, okay? Now, the third part here is to provide the state table, okay? The state table, and you are asked to have A as the most significant bit in the table, and B, the next one. So this is the present state, and this is X, okay? So they're requiring a one-dimensional table, okay? One-dimensional table. This is going to be the next state. No, we just called it D, not A plus. It's both nomenclature are used, either DA or A plus, both used. And this is the output, which is Z, okay? Now let me draw some lines here. I need 8 rows because this is 3 inputs or two states and one input. Okay, so this is 0, 1, 0, 1, 0, 1, 0, 1, and then 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 0. Okay, dA, can see that dA is x complement ORed with ax or b. First of all, where is x complement? X complement is here. So whenever x complement, this is an OR gate, right? We are ORing, right? ORing something with x complement. So whenever x complement is 0, whenever x complement is 1, then this dA is going to be 1. So x complement is 1 means x is 0. So whenever x is 0, regardless of the other expression, I have dA being 1. Okay. Now, whenever x complement is 1, I should look at a XORed with b. Okay, so a XORed with b here is 0. Here it's 1. Here it's 1. Here it's 0. Okay. Now for dB, it is this expression here. First of all, let me compute z because I'm using it in dB. Okay, so z is going to be a complement b, which is 1 only here. Okay, and 0 otherwise. All right, and then finally I have dB, which equals z ORed with x b complement. So whenever z is 1, dB is going to be 1. Otherwise, it is going to be equal to x b complement. X b complement is going to be 1 or b complement x. This is b complement x. Whenever I have a 0 in b and a 1 in x. Okay, 0 on b, 0 on b and 1 in x. 0 on b and 1 in x. Okay, so here it is 1, and here it is 1, and otherwise we have all zeros because we just covered all the midterms here. Okay, so this is the part C. Let me see if there is a part D here. No, there is no part D, but yeah, this is a continuation of the question. But let me stop the video here and continue in the next video. The video doesn't get long.